Hello, dear students. Good afternoon.
Hello.
Hello, good afternoon.
Today we continue listening to the presentations about your thesis work. Today we plan to listen six students, one of them from bachelor, one from first year, and 4 students from second year of our master program. The first presentation from Daria Pirozhkova. Are you here?
Yes.
Okay. Enes Kuzucu. Enes? Not yet. Nikita Nikolaev.
Hello, I'm here, yeah.
Okay. Then Sergey Verbitsky. Sergey? Not here. Dinesh Yerukalareddy.
Yes, Professor, I'm here.
Yes, okay. And Daria Pandey.
Yes, I'm here.
Okay. So maybe somebody other want to deliver topic today? No body. Yeah. Okay. So Enes has come, not Sergey Verbitsky, not yet. Okay, start from Daria Pirozhkova, thesis about study of method for automatic taxonomy enrichment.
Did you see my screen?
Yes.
Okay. Hello, everyone. My name is Daria Pirozhkova, and today I will present my master thesis topic called Application of Neural Network Methods for Automatic Taxonomy Enrichment for the Russian Language. My advisor is Tatiana Batura. Content of this presentation is introduction to the project, task list, project goal and objective, existing approaches, review, data pre-processing for methods, task solving methods, and results. Introduction to the project. My thesis include information about taxonomy, and we should understand what is it. A taxonomy is hierarchically whose tree nodes represent named entities related to other tree nodes with a type of relationships. And is a relation is a domain-independent semantic relation that is a strict partial order relation between a subclass concept and a superclass concept. This relation have 3 properties: antisymmetric, reflexive, and transitive. If a relation is 2-theater, each of the arguments is an entity. If a relation is, in the other words, it's a hypernym relation. It's mean, in the other words, is a semantic relation between 2 words, where the hypernym is a word with a broader meaning that expresses a general concept. Example of this relation you may see on the slide. For our project, second order hypernym is also considered. It's also hypernym. For example, cat is a hyponym, mammal is hypernym for cat, and animal is second order hypernym for the cat. And it's also considered as a hypernym. Also, we can show this relation between entities in table. It's other ways of visualization. We know that it's a relation, and we present on the types of entities, hypernym or second order hypernym. Which task was set in this project? It was the main goal and task formulation, existing approaches review, analysis of thesaurus for taxonomy enrichment, data understanding and pre-processing, and implementation of different methods for classification and the relation between entities. And in the end, it's analysis of result and summarizing.
Daria, 1 second. Can you maximize presentation? Control L, press.
Okay, good, thank you. The project goal and task. The goal of this project is to create methods that automatically enrich any knowledge base with new terms and in the same time connect them with existing words using the relation. And the task is to develop a method for prediction of the relations between entities in text of the computer science category. On the slide, you will see a diagram of task solving, and you may see that we have a knowledge base with terms, and we have a terms list, new terms list, and I should implemented a classifier that can predict the relation between entity from knowledge base and relation between terms, or relation between terms in new terms list. It doesn't matter is a relation or not. If yes, we can enrich knowledge base. If no, so we don't use it. Existing approaches review. Many papers and methods were implemented for English language, but less papers exist for Russian language, especially for last year. In previous year was held competition that was held task for taxonomy enrichment for entity relation classification. So the main idea of this review is most approaches based on the vectorization, classification, and clustering. Less approaches use neural networks, some language models, and exactly neural networks for classification. The hybrid approaches work better than single method, and solution for domain specific is better work than one for language in general. And for Russian language, the result that this language is more complicated than English, and the solution should be maybe more difficult for this language, for solving tasks in this language. And the result of proposed methods don't get good results for practical usage. So it means that it's actual and relevant task. Analysis of thesaurus for taxonomy enrichment. I analyze for 3 thesaurus. I took 70 entities from a manually marked text for analysis. The following knowledge bases: it's thesaurus information technology from so RobertNet and Wikidata. One entity is a term that includes one or more words, and the results of this analysis that more complicated, more fullness of different entities of computer science category. It's Wikidata, and the one word entities is most common than many words entities. Data sets description. We have train data set and test data set. Train data set includes HT annotated text. It's 659 observation with 10 classes, which classes you may see on the presentation on the slide, and it includes 19 easy relation. Test data set is 74 observation with 11 easy relation. The example of from this data set you may see on the slide. We can see that text marked and marked first word and second word, first entities and second entities, and we have classes. And I have an additional data that it's a data set that includes about 1,000 scientific articles in Russian language in computer science category. It's about 100,000 observations. Data preprocessing. I consider it only as a relation, so I converted data sets in binary classes, and I split train data set on train and eval. Train data sets with balanced classes and train data sets with unbalanced classes, but it's got a little worse results, so it doesn't consider in this project. And list of entities of trained data set. What methods were used for solving this task? It's Albert, universal sentence encoder plus CNN, and sentence piece plus neural networks, different combinations. And in Albert was used to different model of BERT base and BERT multilingual. On the slide, you may see architecture of Albert. You may see that we have special tokens CLS, and we have special tokens for entities. You may see this in red and purple squares. So after that, we took we give the sentence in model in BERT and get embedding. And after that, we average embeddings of entities and sentence. And after that, we put it in neural network and have classification. Universal sentence encoder and neural networks. Universal sentence encoder have a deep average networks that average embeddings of all words, and this encoder don't have ability to add special tokens. So it encodes the text without it. And sentence piece plus neural networks. Sentence piece have 4 algorithms for support tokenization. It's a byte pair encoder, anagram, word, and char. In process of project, it was analyzed and definition of the best algorithm. It was byte pair encoder. It works better than other algorithm, and it took for solving this task as a tokenizer. After that, we trained this tokenizer on additional data set. I said about this, and got vocabulary and model, and apply this model on trained data and tokenize trained data, and after that get embedding with Keras layer embeddings. And after that, I have different ways. One of them is concatenate sentence and words embeddings. and put it in RNN. And embeddings of sentence without words embeddings put in RNN, CNN, LSTM, and CNN plus LSTM. So it's very interesting for me how it looks like on the graphs, how we can visualize these entities. It's graphs. There you may see the entities two different ways. One of them entities with is-a relation, and other with its other relation. Have other relation. It's visualize BERT embeddings with T and E, and we may compare this with visualization for sentence piece tokenizer and keras layers embedding. We can see that it's different visualization, different position, and different embeddings. I think it's very interesting. It's have different different places, different numbers for different words with different relations. Results of this project. The results in the results I got this metrics, and BERT on BERT-based multilingual case got the best results for this task, and got 72% for one score, and 86 Roka score. It's highly than other methods, and methods using universal sentence encoder and sentence piece and neural networks received worse result if one score less than 50%. Why I got this result? BERT-based multilingual was pre-trained on a lot of language text, and includes Russian text, and it's more large, so it got best results. And universal set encoder don't have special tokens, so this encoder don't see marked entities, and special and sentence piece and neural networks give different results. So you may see also the examples of mistakes in prediction for RBERT multilingual. You may see that which entities this model predict incorrect, which is this predicted as other, and other relation predicted is a relation. So also about publication, and it's this project had 2 publications. You may see on this slide. So it's all. Thank you for your attention. If you have a question, I will be glad to answer.
Thanks. These questions. I have a question. How you can deduce errors into, like, what the main reason for these errors? Like, how you analyze? You found these mistakes, and then what conclusion you can give?
You may see these mistakes, yes, between entities.
And what's behind that? Why these errors appear?
It's a very interesting question. I think because it's not usual words, and maybe the model didn't face this word before, or this word have the similarity embedded. So it maybe it may be a reason for errors for a model.
Okay, other questions? Please, previous slide, show again with publications. Yeah. Okay. Okay, thanks.
Thank you.
So let's go to the next presentation, and Enes, are you here? Enes? No. Then Nikita Nikolaev, please.
Okay.
Так, ну что, Рокет?
Just give me a minute.
Нет, подожди. Там разматывают,
Okay.
а тут бавят размат.
Good afternoon, dear audience. Today I would like to present to you my master thesis, which is called Zero-Shot Learning Approach to the Problem of Short Text Classifications. My scientific advisors are Ivan Yuryevich Bondarenko and Tatiana Viktorovna Madura. And let's start with a short outline. First of all, we will talk about a brief description of Zero-Shot Learning approach and all the related tasks. Then we'll move on to overview of the proposed data and solution. We'll see results of this work and finalize our discussion with the Zero-Shot Eval special pipeline and framework for this work, and some conclusion. Okay, and let's start with the first part. And I'll start with the brief description of the task. So let's start with the classification problem. It is well known that classification problem in general is one of the most common tasks in machine learning, and it is also known that to build robust classifier, we need to have a good data, which is balanced and representative. But in the real world, we can meet a lot of situations when data sets are unbalanced. And for some classes, we have a small amount of instances. So here we have to solve a task which is called few-shot learning, when for some classes we have a full data set, and for some classes we have only several instances, for example, several images, and train such a good classifier that will classify your objects as good as usual task. I mean when the data set is full. But if we turn to more real problems, we can meet data sets when some classes have no instances at all, and then we need to switch to zero-shot learning setting. And this approach is aiming to solve a task when some classes have no instances at all. And we need to build a classifier that will classify and recognize these, for example, images or texts, and classify it correct. But how we can do it without any examples of some classes? How we can build a good classifier? So the answer is quite simple. We need to use some additional data which can help classifier to understand the main the main description of classes, and then transfer knowledge from seen classes, from known classes to unknown or unseen classes. And on this slide, you can see the formulation of the reshort learning task when we have two sets, I mean, seen classes and unseen. And let's talk about additional data modalities. First of all, I need to say what is data modality, what data modality is. And data modality is just another representation of the same data. For example, if we have some text and if we can have for it, for example, tags for each text. For example, if we have a movie review, then we can have a text for this review, or we can have some text and then we can have some description of this text. And the main idea of this approach and to build a shared latent space to which we just map our initial instances, initial modalities, and somehow connect these modalities in this space and build a classifier using this shared latent space. And this will be performed during the training of the whole network. So that is the main idea, how to solve the reshort learning task. And this approach is quite general for all kinds of the reshort learning tasks, the reshort learning related tasks. And from this point, we need to see the data. And let's start with the overview of the data and solution. And we need to define which data can be used for this setting. As I mentioned earlier, we will solve, first of all, we'll solve a classification problem and a text classification problem. So then we can have a data set which consists of texts with its labels, and we have some passes. And here I will talk about the Dvpd data set. This data set is intended for classification of ontologies. And in this data set, we have 14 non-overlapping classes. And the total size of training data set is 560,000 instances and 70,000 instances for a testing data set. And the main thing we need to mention is another data modality. And for this data set, we defined a second data modality as classes descriptions as the second data modality. We have 14 classes, and you can see these classes here. We have some company, artists, athletes, and so on. And we can just take the definitions of these classes from Wikipedia, and this will be a small text which consists of a couple of sentences, and use it as an additional modality. Okay, and the next thing is how to use these two modalities, how to train a classifier, how to train the full network, and build a final classifier. So here the main idea is to use variational autoencoders, as we need to build a shared latent space for mapping initial instances, initial objects into this latent space. We just decided to use variational autoencoders to build such a space. And you can see the scheme of this approach and this network on the slide. So we have two modalities. For each modality, we have its own variational autoencoder, which is depicted here. Here we have input data, some additional modality, and at the output we have reconstructed inputs and some parameters of the network. But if we will just train a variational autoencoders, we will not get the result that we want. We need to build a shared space. So then we just move on to loss functions that we will use here in this network. And here you can see three main parts. We will use three main loss functions. First loss function is devoted to autoencoders, which is needed for autoencoder to train. The second one is cross-alignment loss, which depicted here. You can see these arrows, and this loss function allows us to build a shared space, and distribution alignment loss, which allows us to build a consistent feature space. So let's consider all these loss functions in a bit details. And the first one, the simplest one, as I think, is variational autoencoder loss. Here we have a standard variational autoencoder loss, which consists of two parts, the information gain and callback labor distance, which we are minimizing between distributions of data that we have the input and on the output, because our variational autoencoder tries to reconstruct our inputs through the latent space. So we just encode it to smaller dimensionality and then reconstruct it to the full output, to the full input. And that is all for this part. The next thing is cross-alignment loss. Here, the idea is also simple. As you remember on this slide, we see these cross arrows, and the idea is to just train the whole network and train each variational autoencoder to construct not only its modality, but the modality of the another modality. So here we have, for example, input. Then we just encode this input with one encoder I, and decode it with decoder G and J, sorry. And here we have just a sum of all the modalities, and that is a loss function that will train our network with the cross features of crossing two modalities. And the third loss function is distribution alignment. Here we have two distributions because we have two modalities. Each distribution is a multivariate Gaussian distribution, and we have a Weierstrass distance for minimizing this distance between two distributions. And for some simplifications, as we have diagonal covariance matrices, we can have this form, and the final loss function is just sum over all the modalities of Weierstrass distance. And the final loss for the full network is just sum of these three parts with some scheduling constants, and that is all. That is the main idea of this network, that we have these loss functions. Okay, let's move on to the results, and here we have this table. So as we I need to mention that this task, I mean zero-shot text classification, is quite new, and there are a small amount of solutions, and the proper way to compare the results, one of the proper way to compare the results is just to take a usual classification networks. For example, classifier based on ExcelNet, BERT, or ULM feed, which is intended just for usual classification, and compare results of our network with it to understand how good is it. And here we have the error rates for classification, where you can see that ExcelNet provides us a state-of-the-art for currently it's state-of-the-art for text classification on dataset Dvpd, and error rate is just I mean accuracy is just almost 100%, 99 and 4. And here we have our results, that our accuracy is 99%, and the main results is that our network can work in the zero-shot setting. And here we have an additional accuracy for unseen classes. And for other networks, we have no such results. And that is the main result of this paper, of this work, that we have built a network that shows as good that shows a good results for usual classification, yeah. And we also have an additional way how to classify classes that we haven't seen before in the training data set. So that is all. And the last thing to mention is that for building such a network, we used a special framework which we developed for this purpose, for this task, and that is very short while. This framework allows you to build several experiments with different settings and different networks, different data sets and evaluation procedures, and that is our the second main contribution to this work, because we need to move to conclusion. As this task is currently explored field and task, and it has a great potential, and we have small amount of solutions, and all the solutions that already exists, they are just differs a lot, and we need to build a framework that will allow to compare all the results that exists, and have the good table, for example, for comparison. And more problems which we have faced is problem with data sets, that there are no specific data sets for zero-shot text classification, and in this work we just adapted a usual text classification data set for zero-shot learning setting, and probably we need to construct specific data sets for these tasks. But even with usual classification data sets, zero-shot learning approach allows to achieve comparable performance with the usual classification models, but with a greater perspective of application. So that is all, that list of references, publications. And this work was published on International Scientific Students Conference and took third place. And that is all. Thank you for your attention. If you have any question, I would love to answer it.
Thanks. Yes, please, questions.
I have a question. How many labels model C and unseen?
How we can label seen and unseen classes, right?
Yeah.
Yeah, that is a good question. Thank you. In this work, we just fixed this split on the seen and unseen classes. As I mentioned, we have 14 classes, and as I remember, we took 9 classes as seen and 5 classes as unseen, and this split is just fixed. But we can vary this split and try other splits for this training and achieve another results. But I think that will not change the results at all, because the general ability of the network to transfer knowledge from one classes to another is just unchanged, will be unchanged.
Okay, thanks.
Any more questions?
I have a question where you define loss function. Is it your proposal or it's already proposed in some papers?
Yeah, thank you for this question. These loss functions were proposed in the paper, which was published, as I remember, in 2018. And that's just loss functions that it is a general approach how to solve a zero-shot learning task. And this loss function is quite general for this kind of task. And yeah, That was
Okay.
already presented. Yeah.
So if it's general, what is please during pre-defense highlight what is your contribution, like what is novelty if you took already defined loss function, where is your new value in science?
Okay, I can answer it simple because actually this task, I mean, zero-shot learning text classification is quite new. And as you can see in this table, we have no comparisons with other solutions for exactly this task, because it is already solved for some other settings. I mean, there are some works devoted to this topic, but we can just compare with it because they have another data sets, another settings, another requirements, and so on. So if we will consider exactly this task, simple classification with the seen and unseen classes, then we have no comparisons at all, and we can build a comparison only with the usual classification. So the novelty is that we just solve this task and proposed a result that align with the usual classification, and that is great, I think. And yeah, we took loss function from the other work, but the full solution consists not only from the loss functions. We have also networks that we should do find, and we have a lot of parameters to build, and we have a lot of work with the connected with data. I said that we have no specific data sets, so we need to adapt some data sets for this kind of task. And so the loss functions is just a part of this work.
You adapted data sets, you applied, okay, I understand. Thanks. Other questions?
Okay, thank you.
No
Thank you.
questions. Thanks.
Thank you very much
again.
for good questions. Thank you.
And let's continue our seminar with the next presentation from Enes.
Hello, can you hear me?
Yes, I can see.
So, hello everyone, my name is Enes, and my thesis topic is estimating average response time for stop-signal paradigm from electroencephalographic signals. So my presentation will be brief. And first, I will talk about the task, and I will talk about the data, and last, I will talk about the current version of the model I'm planning on using on this task. So basically, stop-signal paradigm is an experiment where subjects are given a task and they prepare to stop at a suddenly given stop signal as fast as possible. We record their reaction time, and at the same time, we record their brain's electrical activity. This activity is called EEG signals, and we can make use of this data to learn more about cognitive behavior and how the brain works. And in this study, the question we are asking is it possible to estimate a person's cognitive inhibitory ability using EEG data? And can we make a classification based on their inhibitory response time to show that age groups and gender features are actively affecting response time or not? So we have a small but interesting and rich EEG dataset gathered from Yakut people, which are known for their hunting skills, which allows us to make assumption that their attention cognitive skills are sharpened through hunting. And also we have each subject's medical backgrounds, and also we have their DNA for the feature domain correlations and connections. Can you hear me?
Yes, we can, like some latency experience.
Okay, I think this will be okay now. Right now it's okay, right?
Yes, it's okay.
Okay, thank you. So here you can see at the left, topography of the electrodes placed on the subject's scalp. Electrodes placed with 10 to 10 international system. And in the right, you can see the summary of subject 11's collected data. Let's talk about data sets. Our data set consists of 100 samples, and EEG signals were recorded using 62 electrodes, and we use 10 to 10 system. And when we, also 0 to 100 Hertz analog bandpass filter applied during data acquisition. And in addition, vertical electrooculogram was recorded for detecting eye movement artifacts, which allows us to eliminate this noise from our main signal. And each subject experiment consists of around 100 iterations, which means there were 100 stop signal tasks per person. Here you can see all the recordings from 62 electrodes for subject 11. Green vertical lines represent start of the stop task, which means subject has been signaled to unpress the button, and red lines are actual time subject reacted to this signal. The time difference between green and red lines show us the inhibitory response speed of individual subject. So if we take only one channel, we have 62 channels, and segment each stop signal event to different epochs, and layer by layer, if we order all the segmented data such way that they align in time dimension, and then if we compute the power density of the signal, we will have activity map for that particular channel. In this picture, you can see this. And here you can see the vertical black line. It is the start signal, and approximately 500 milliseconds later, you are seeing red vertical activation cluster. This is brain's response to stop signal. And if we stack all these like vertical layers together, and we will get a ERP. In here you can see this, which means event related potential. And in this ERP signal, we can clearly see the change caused by the stop stimulus signal. So we have certain heavy problems with this task. Our first problem is cognitive behavior and inhibitory response time is something that changes over aging and tiredness of the subjects. And in our data, we have different age groups and different genders. And also our data is only consists of 100 samples. The second problem comes from the nature of the EEG data, which is extremely non-stationary. And EEG data is very weak with cross-subject classification dependent features. This means that features are highly subject dependent, and even if we have good test results for the same subject, our trained network will work poorly with another subject's EEG data. For better understanding the task and the data, I summarize and take notes from more than 10 articles which conduct various EEG signal classification tasks. And mostly I focused on modern methods and some innovative models to achieve better representation of human brain in our system. Everything is okay, you can hear me still because my network is...
Yes, we can hear you.
Nice. So sorry for this. Yeah, so the main ideas I get from this articles is that we want to have a good representation of the brain system. And we already know that EEG data events are time-dependent signals, and to interpret them, we might need to check the data as a whole. With this understanding, treating EEG data as a sequential data and using RNNs makes sense. However, when I focused on this kind of work, I found a study in Stanford, which explains experiments with vanilla RNN networks are not providing any improvements for classification tasks for EEG data, and they are suggesting using more complex RNN models. So I narrowed my search, and I found that LSTM has been widely utilized for learning and classifying time series data, including biosignals. Some recent studies have successfully used LSTM architectures for EEG analysis. Also, since we are interested with certain parts of the signal, we can make use of the attention mechanism by focusing on certain time steps, which leads us to make use of attention-based LSTMs. They are popular and they are widely used for all other tasks also. So our second approach idea is to preserve spatial relationships. So most works either only consider EEG as a chain-like sequence, and they neglect complex dependencies between channel signals. And they perform single temporal averaging of all EEG sequences, which makes lose all the special features actually. So one of the papers I come across the idea of preserving spatial features. And in this paper, it's explained that we can create a matrix which corresponds to each location of the electrodes. And then when we are feeding our model, we can also feed the position matrix with our model. So our model can learn spatial features among other features. I am still searching on this topic. I want to see if I can improve this idea by using a 3D matrix so we can have a better representation of the spatial features in our model. So EEG data is like by itself, it's really hard to interpret, and finding the correct methods will take, I think, more time. Currently, I'm searching for parallel usage of CNN and LSTMs, and I want to use of wavelets, spatial features, and statistical features together. So I need some kind of like fusion method with them. My research is still going on, and this is all for my presentation. Thank you very much.
Thanks. Please, questions? Okay, no questions.
Thank you very much.
Seems no questions. Okay, thanks. Sergey Verbitsky. Not here. Then, okay, so we'll listen to the next presenter, Dinesh Yerukalareddy, his thesis on brain tumor classification.
Good afternoon, everyone. Can you my screen? Can you see my screen?
Yes, yes.
Thank you. Yep. Good afternoon, everyone. Today, I would like to present my master thesis topic on brain tumor classification from MRI images using extensive data augmentation. My scientific advisor is Evgeniy Pavlovskiy. So here is the outline of my thesis topics that I will be covering here. So first, starting with problem statement. So coming to problem statement, the presence of brain tumor among humans has increased in large amounts in recent years. So actually radiologists requires a lot of time to manually annotate and segment these images. The well-timed detection and classification of the tumor can add to better accurate treatment and can increase the survival rate of patients. So over the several years, like deep learning has been playing vital role in the field of computer vision. So one of its key uses in the medical industry is to minimize misdiagnosis and the amount of time taken to annotate and segment those images. So currently several methods exist for tumor classification, but they all lack high accuracy. So in my research, my goal is to improve the performance and also to reduce the complexity that involves in the medical image classification process by using CNN with extensive data augmentation. So coming to introduction, brain tumor is an abnormal growth of tissue in the brain which can lead to death if not detected early, if not detected at an early stage. Brain tumors can be cancerous, that is malignant, or non-cancerous, benign. Like most common types of brain tumors are meningioma, glioma, and pituitary. So one of the tests to diagnose brain tumor is MRI. So MRI scan is preferred because it is less harmful and more accurate than CT brain scan. So coming to data set description, so for my thesis, like I have used two different publicly available MRI data sets. One is from Tianjin Medical University, which consists of 3064 T1 weighted CMR images that were obtained from 233 patients. So we have like three kinds of brain tumors in this data set: meningioma with 708, glioma with 1426, and pituitary tumor with 930 slices. And the second data set I have collected from University of North Carolina. These data the data available are from 20 healthy volunteers comprising MRI images of 100 healthy subjects which were scanned per decade with different age groups, and also with the exclusion of any subject with a history of any disease that affect the brain. So it means like it's like healthy brain images. So here are the samples of the tumors like glioma, meningioma, pituitary, and healthy no tumor. So coming to the method, so here I have used two methods. Like one is using transfer learning and one is using GAN as a pre-trained model. So first I will gonna discuss about using transfer learning techniques. So like in my research, like I have used some of the pre-trained models like ResNet 50, VGG16, Inception V3, and Exception for classifying brain tumor. So like by applying the method of transfer learning, like these models were trained as a whole, like without using ImageNet weights, by using augmentation and also without augmentation. So I have given a comparison at the end, which I will be showing later. So like some of the augmentation techniques I have used are like rotation, center crop, and resizing. Like coming to rotation, like here I have used some angles like 45, 90, like 135, like that I have used. So one image will generate like 7 other images. So totally it will be like one image will generate one image will have 8 images along with that original image. So second method is using GAN as a pre-trained model. So here I have introduced a new approach by using a pre-trained discriminator in a GAN, um, with the help of MSG GAN along with auxiliary classification to extract the features and to classify the images. So like in the discriminator, like we will be having like the fully connected blocks acts as an auxiliary classifier, and the other fully connected block acts as an adversarial layer. So it's similarly to normal GAN, but like I have added another layer with auxiliary classifier. Why? Because using auxiliary classifier, it helps the discriminator maintain good feature extraction and also and prevent mode collapse. So also it helps in ensuring that our generated data maintains a condition like class. So while training GAN, so I have here I used angle augmentations like 40, 90, 120. These are the different angles, different angles of augmentation I have used for the original image. So as I said, this GAN is similar to normal GAN, but with slight some changes. So here, mostly it's like MSG GAN, but like there are some changes like output. The one of the fully connected layer is auxiliary classifier, which I have added. So if you see like if you see here, like here the latent vector and label will be the input that are passed to the embedded layer, and then the output from the embedded layer is passed to the convolution 2D transpose layer, here where the deconvolution takes place and produce the image size of 4x4 from the input. Then it will be subsequently passed to n number of upsamples and upsample and convolution blocks to produce an image by increasing the resolution of the image. So it's like 4x4, 8x8, 16, 16. Next will be 32, 32, 64, like till 128, 128. So like I have used like my output generated image will be of 128, 128. Coming to the discriminator, like as I said, like here one of the fully connected block we have here, it was auxiliary classifier which I have added. So like here the discriminator requires the image as input, like the image from the generator, the image from the generator output will act as an input for the discriminator, and it is downsampled by 2 at every stage by using a convolutional block and average spooling. So then like it is then passed to mini batch standard deviation. um, so through this activation maps are created. The outputs of the mini batch standard deviation will be passed to the convolution block, convolution block, and then pass to these fully connected blocks. So one here, as I said, like one of the block will be acts as auxiliary classifier for classifying the input image belongs to, and the other fully convolutional block acts as an adversarial classifier, which is common in normal GANs, to determine whether the generated image is real or input image is real or fake. So here are the results. So like these are the transfer learning techniques, and these with GAN as a pre-trained model which I have used. So without augmentation, these were the results, and like with augmentation, these were the results. So for exception, like I have reached 98.79 and 98.57. So these by using this transfer learning method, so like we can still improve accuracy, like by fine tuning and all. Like so far, like by after fine tuning, I have achieved 98.79 for exception as highest, and like with my proposed GAN with CNN 98.57. So comparison of the proposed approach with previous work. So as I mentioned, like these three are like using transfer learning techniques. So my exception got 98.79. So these two papers were related to GAN. So here, like I have achieved 98.57, which is pretty better than the other paper. So yeah, finally conclusion, like as I said, like here, like I presented a new approach for classifying brain tumors using GAN as a pre-trained model, and also use some of the pre-trained models by applying the method of transfer learning with augmentations and without augmentations. Our results indicate that the proposed approach improved overall performance, and as well as prevented from overfitting. So these technique can be useful. This technique can be useful when the availability of data is limited. So coming to like future scope, like I will try to improve architecture to generate more realistic MRI images of higher resolution. So far here, like I used 128. So next I will try to use 256. The reason because like my input data size is of 512. So all these transfer learning techniques required input size of 224 or 299. So we need to resize, and also so to tackle imbalanced data set problems, like we can improve in the future, like I will try to improve my architecture to generate like more realistic MRI images of higher resolution. These are some of the references. Yep. Thank you. Like, any questions?
Thanks. Please, questions?
Sorry, in the beginning, I think you told that you use rotation as augmentation for training gun, right?
Yes.
But there exist problems with augmentations, with augmentation for guns, that your augmentation will leak into your generation. So I wanted to ask, isn't it a problem that rotation will leak in the generated MRIs?
So actually, yeah, it might leak, but the thing is here, like I haven't used my generated images for my model. So here, like my main focus was improving the discriminator for feature extraction. So coming to your question, like here I have used angle augmentations to overcome the problems of translational invariance. So like while training the GAN. So actually, like my focus was like to generate higher resolutional images, but like while using data augmentation, I read some articles like data leakage might be happening. So at the end, and also like for generating high resolutional image, it requires higher complexity. So I stopped using these generated images as of now. Like for my thesis, just I used discriminator as my feature extractor. But like in my future work, like I will try to improve my architecture to generate more realistic images, like without data leakage, and also.
Okay, thank you.
Okay, thanks. If no more questions, yes, then thank Dinesh for answering questions.
Thank you.
And we pass to the final presentation for today from Kavalya Pandey. His results on the topic of improving sentiment analysis for stock trends prediction.
Hello, everyone. Good evening.
Good evening.
So my topic is to improve the sentiment of the financial news, which we can incorporate and take leverage from this news to predict the trend in the upcoming stock. So I used two different data set, but at the final, I decided to use S&P 500, which is Standard and Poor 500 companies of United States. And the news data I used from the Reuters and the Guardians, which is specifically collected, which the news which affects the stock price of S&P 500. So as we know, like stock market prediction is like one of the very difficult tasks because it is highly volatile and the noise in the data and the factors which can affect it are very much diverse. So there are some research going on in this since past decades. So support vector regression and support vector machines, these algorithms have been widely used to predict the financial time series and to gain the accuracy. So as the efficient market hypothesis suggests that stock price reflect any change in stock price is due to its previous historical data of the time series plus the events which can trigger it. For example, suppose Elon Musk bought the bitcoins and then the price of the bitcoin suddenly goes up, or he tweeted about something and then the price goes down. So these are the event effect on the prices of the time series. So my proposed model is a hybrid model of CNN plus LSTM, which is used to predict the trend, whether the stock will go up, which I denoted by 1, or whether it will go down, which is denoted by 0. So I used the S&P 500 historical data, which consists of its close price from 20th March 2018 to 14 July 2020, and the same financial news from Reuters and Guardian, and I combined this news from same duration of 20th March 2018 to 14 July 2020. So as I told, I denoted the trend as 0 and 1 if the price is decreased, so it's 0. If it's increased, it's 1. And I also generated some technical indicators which the traders in stock market mostly use. That is the moving average of the close price and exponential moving average of the close price. So I combined, so as we use LSTM for the time series, so we can make 3 days, we can take 3 or 4 days data and predict the 5th day data. So I tried different windows, and the highest accuracy I achieved was when I combined 3 days news with the 3 days close price along with its moving average from past 3 days and exponential moving average for last 3 days to predict whether the stock will rise or will fall on the day 4th. So here is the model architecture. So first I used glove embeddings to generate vectors of the news, and then I used embedding layer by which I generated the vectors. After that, I used 2 convolutional layers. First convolutional layer was having 256 filters with kernel size 10, and another convolution layer with 64 filters and 5 kernel size. After that, I used max pooling layer with the pool size of 2, and then I used the flattened layers to get a final tensor of the vectors. And similarly, in the other model, I used the historical data of the S&P 500 and feed it into LSTM and with a dense layer. Then I used Keras concatenate layer to merge these 2 models, and then I added another dense layer with the softmax activation function, and then finally output. So the activation functions which I used for LSTM was sigmoid, an optimizer Adam with the learning rate of 0.01, and at the last layer I used the binary cross entropy loss while compiling the model, and I run this model for 100 epochs. So my training data was of 436 days and testing data was 109 days. So for 109 days, I predicted like whether the stock will go up or down. So here are some baseline results. So as we can see, rand is for a random guess, which is like flipping a coin. So it's like 50% accuracy. Then there was a good work done by Brown in 2004 using ARIMA for this task, and he achieved accuracy of 51.4%. Then support vector machine accuracy was 56.38%. So here F1 score of these results are not available, so I was not being able to see what was their F1 score. Then this was the attention based back LSTM, which achieved the accuracy of 61.93%. And similarly with Ding, he achieved this accuracy in 2014, and then in 2015 he increased this accuracy to 64.2%. So the state of the art currently in this task is knowledge graph embeddings using CNN, which was work done by Xing. So he achieved accuracy of 66.93%. But the news data which he used, it was very huge. He used news from 8 years, which I was trying to find, but previously it was available open source, but now it's not available. It is written, they removed data set. Then our result are 66.05%. So my model out of 100, averagely 100 days, 66 days, my model predicted right. And this is the F1 score of my model, 0.77, which is like satisfactory results. So I think like this accuracy can get increased if suppose the news which we are using should be will be collected by the financial specialist, which know which news is suppose is affecting the stock price. So we will get more S&P oriented news, so it can increase the results. Thank you very much. So any questions I would love to answer.
Thanks.
Hello.
Hello. Yeah.
Yes.
Yes. I'd like to clarify if your research work is more on the technical analysis rather than the fundamental analysis side.
Yeah, it's technical analysis.
Okay. Have you tried considering the sentiment analysis? Let's say you have mentioned about the parameters of the news events in determining the price movement. So maybe you could also consider these other sources of news so that you can have a better estimate in the price movement, and then try to compare with your technical analysis. Because based on what I have read, if you focus morely on the technical analysis, let's say for example on the Elon Musk in buying a Bitcoin, there's actually a delay in the price movement predictions of the technical analysis. So perhaps if you can combine technical and the fundamental analysis, maybe you have a signal. Let's say you read a sentiment analysis of Elon Musk buying a Bitcoin and other sources of information that could trigger or predict the price movement directly. That with those positive news, by tomorrow there will be an increase. The stock price would increase. So with that, with that process, you have an advantage on when to buy or when to sell the stocks at a maximum value.
Okay, I understand your question. What you are trying to say is, suppose a news came and it will affect maybe tomorrow or day after tomorrow on the price. So that is I implemented already. It's like called as lags. So suppose today's news can affect the stock price of the day after tomorrow. It is not necessary it will affect the price tomorrow. So that's why I run different combination to find which is the best lag. So the 4th day lag is the best, like, because when I tried for the previous another lag, so accuracy was 63%. So it is right. And what you are trying to say is like sentiment analysis. I think this using embeddings is a more good approach than calculating sentiment score, because like sentiment score is a general, so it can affect some companies in the positive and some companies in the negative. Suppose Elon Musk Bitcoin example, so it can affect the increase in Bitcoin price, but maybe it is possible it will affect the decrease in other cryptocurrencies or other stocks, like Ethereum or Dogecoin, anyone.
Okay.
So that's
maybe you could also include when to enter the market after you have those informations of the price movement. So when is the right time to buy or sell the stocks?
Yeah,
maybe you could also
this is like in my mind, but right now I was not being able to implement. So the thing is to try reinforcement learning and train our agent to
Yes.
deal directly based on the news and this historical movements. So yeah, there is one library developed by AI for finance. So it is used reinforcement learning Finarel library to, which is basically only based on technical analysis. So they read the candlestick charts and other technical indicators and decide when to buy and when to sell. So they do like frequent transaction, which is not possible by the human. So that's why many companies who are in this field are trying to implement this. But as more and more companies are being employing these technologies, so the result of these technologies are also diminishing. So like 5 years ago, it maybe reinforcement learning was giving us very good ROI on our investment, but right now it's decreasing because the more people are using same technique, its results are decreasing due to the market because market adjusts itself.
Mm.
Okay, thank you very much.
I have one more question. Is this technique of yours applicable for short-term trading or long-term trading
Yeah,
or
it is
both?
basically based on day trading, where you have
Okay.
yeah.
Yeah. Okay. It
Yeah.
would also be good if you could also consider the long-term trading.
Yeah, it is possible, but actually, but when news it basically affect stock price for short term, not for long term. For long
Mm.
term, I think analyzing the company's financial reports are more good approach.
Yes. That would be one of your parameters in the price prediction.
Yes,
So thank you for the presentation.
thank you.
I have also
Yes,
one
please.
question. Do you think that accuracy is a good metric for estimating the quality of some training bot, or I don't know how to call this correct? Because, for instance, it can guess correctly when price will rise or drop down on 5%, but it predicts incorrect when prices are drop on 40%, and then you just lose all your profit and
Yeah, thank you for
money.
question, Andre. Actually, right now, what I did, we didn't focus on the percentage changes in the price. We just focused like if it's in minus, then it's a decrease. If it's even $1 increase, it's called as an increase, which is used in day trading basically. So what you are trying to say, it is accuracy is good on this approach, which I implemented. But if you are trying to trade, then the ROI is more good to assess because then the percentage change will make a huge impact on the investment. Suppose the increase is 40% and model predicted right on and bet on that trade. So then on that time, like return of the portfolio value will be the good metrics to assess, which like they did in financial reinforcement learning library. So that is like to trading basis. It is one of the like how to say, there are different hands in the trading agent. So this is like one of the hand of that trading agent. I hope I cleared my answer.
Okay, thank you.
Thank you. Any other?
No questions. Thanks, Kavali, for answering questions. And that is all for today. Do you have questions, proposals? Next day there will be a pre-defense for second year students. It will hold offline, but will provide also online possibility to participate our Watana for Watana only. All other students need to be here. Please take with you printed copy of your master thesis drafts. and good luck.
I have a question. Is it okay if we remake this draft after pre-defense?
Yes, it's draft.
Okay.
Yeah. The paper, the drafts will be seen usually in the case of the presentation leak of information. Like if you do not provide enough in presentation, then committee will look into the documents. If in the document there is also nothing to understand, to distinguish it, like the main question is what main scientific contribution by your work? If no answer, then like it may be a problem.
Okay, thank you.
If I may ask, what are the main content of the, should we put on the slide since we have only 5 minutes?
Not 5, as I remember.
5 plus 2, like 7, I guess.
Yes. So you need to claim your results, like the work done. The final table you have some comparison with another baselines, your result, and the information needed to understand your contribution. So one slide, it's about overview of present work done by other researchers. Second slide, some introduction in your topic, maybe 2-3 slides. Yeah, you introduce what's the task you are trying to solve. One task for your 1 slide or 2 about your methods proposal and results. Like around 10 slides. In 5 minutes, you can show effectively 10 slides. If more, then you may fall into too fast switching from one slide to another, and committee will not get. We need to understand that the committee may not know your domain on which you are working. That's why you need to introduce one slide, but not too much. No one, I suppose, will get too into details except the scientific advisor and reviewer. So tomorrow we will estimate your readiness for defense and state the reviewer.
In which format we should provide the information about our review?
Orally, and then text me in chat. So okay. We like by committee we need to state that this reviewer is formally good, so like no affiliations with your scientific advisor, and that is an expert in this domain. Okay.
Okay.
And we are supposed to find a reviewer by tomorrow.
Yes.
Are there, does the department provide like a list of reviewers available, or nope?
It's usually a headache of scientific advisor.
Okay.
Okay, if you will have how many people of committee from mathematical center, it's 3 persons, and to each all scientific advisors, so it will be like 10 persons of committee. Okay, see you tomorrow. If any other questions, please write in chat. Goodbye.
Okay,
Goodbye.
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 Bye.